So welcome back. So today we're going to continue with Pure Maths 1, October, November 2024, variant 1. Okay, so we're going to continue with the question number 8 to question number 11. Question number 8. It is given that beta is an angle between 90 to 180, which is an obtuse angle such that sine beta equal to A. So here what we can do, express tangent square beta minus 3 sine beta cos beta in terms of A. So here what we can do is first we try to draw the triangle on the second quadrant. So I just randomly draw. Okay. So this will be your beta. Okay. So sine beta will be A. So will be A over 1. And here will be cert 1 minus A square. And since it will be on the left hand side, so it will be negative. Okay, it's the left hand side of the thing. It's the second quadrant. Okay, so express tangent square beta minus 3 sine beta cos beta in term of A. So tangent square beta will be, so tangent will be A over negative cert 1 minus A square minus 3 sine beta is A and cos beta will be negative cert 1 minus A square. Therefore, the final answer is going to be A square over 1 minus A square plus 3A cert 1 minus A square. Okay, that's it. For B, solve the equation of sine square plus 2 cos square plus 4 sine theta plus 3 from 0 to 360. Okay, so for this, we do have terms in term of sine and also we have term in term of cosine. So if you look at this, it looks like a quadratic equation because there is a sine square and sine the linear term and also a constant here. So it looks like a quadratic term, but the problem here is we do have a sine square and cos square. So what I'm going to do here is actually we are going to convert my cos into sine. Okay, so how we can use sine square theta plus cos square theta equal to 1. So from here you can say it cos square theta equal to 1 minus sine square theta. So we use substitute here in 1 minus sine square. So it's going to be sine square theta plus 2 1 minus sine square theta equal to 4 sine theta plus 3. So it's going to be sine square theta plus 2 minus 2 sine square theta equal to 4 sine theta plus 3. So negative sine square theta plus 2 is equivalent to 4 sine theta plus 3. So we rearrange and make it the a's positive. So it's going to be sine square theta plus 4 sine theta plus 1 equivalent to 0. Okay, so we can factorize this. So we're going to use the quadratic formula. So if you still remember your quadratic formula, x equal to negative b plus minus square root b square minus 4ac. Okay, over 2a. Okay, so we're going to use that. So it's going to be sine theta is equivalent to negative b plus minus square root b square minus 4ac over 2a. Therefore, sine theta equal to negative 4 plus sec 12 over 2, or sine theta equal to negative 4 minus sec 12 over 2. Okay, so if we convert this into decimal number, it's going to be negative. So if we convert this into decimal number, sine theta is equal to negative 0.26795. Therefore, I go into the reference angle, find the reference angle. So the reference angle will be 15.542 degree. So since sine negative, your quadrant will be second and third quadrant. Therefore, theta will be 180. For the third quadrant will be minus 15.542. Okay, and your fourth quadrant will be 360 minus. Sorry, it's plus, not minus third quadrant. Minus 15.542. Therefore, the theta will be 195.5 degree and 344.5 degree. Whereas for this, sine theta will be negative 3.732, and this is actually not between the range. So if you realize, your sine theta must be less than 1 to negative 1. So for this, we reject this, or we can just ignore. Okay. Question number 9. The equation of a curve y equal to 4 plus 5x plus 6x squared minus 3x cubed. Find the set of values of x for which y decreases as x increase. So when y decrease and x increase, so for example, we just draw a simple graph. Okay, the y is decreasing as the x is increasing. So it's something like this, correct? It's this way. So y decreasing, x increasing. So like from for example, at this point, we just compare this. So y1, x1, y2, x2. So from y1 to y2, y decrease, but from x1 to why I do like this? Sorry, yeah, it should be x1. Okay, sorry. So x1, y1, x2, y2. So if you notice y1 and y2, so as the y decrease from one point to another point, okay, from point 1 to point 1, y1 is smaller than y2, whereas my x increase, x1 larger than x2. So this shows that my dy over dx is actually negative, less than 0. Okay, so as the y decrease, x increase means your dy dx is less than 0. So we find the dy dx first for this. So my dy over dx will be 5 plus 12x minus 9x squared. So for dy dx less than 0, it's going to be negative x squared plus 12x plus 5 less than 0. So usually for my thing, I will make sure my a is here is positive. So to avoid some confusion, so I just make it a as a positive. So multiply everything with negative 1. So 9x squared minus 12x minus 5 is more than 0. Okay. So when you factorize this, will be 3x minus 5, 3x plus 1 more than 0. Okay, so from here the critical value will be x equal to 5 over 3, and my critical value is negative 1 over 3. Okay, so negative 1 over 3, 5 over 3. So since it's more than 0 is this region, therefore x is smaller than negative 1 over 3 and my x is larger than 5 over 3. Okay. For B, it is given that 9x plus k is a tangent to the curve. Find the value of k. So they said it is tangent to the curve. So let's say the something like this is the curve. Let's assume. Okay. At this point, the tangent is this. Okay. So this is a tangent. So what I know from here, it is 9x plus k, which implies that the gradient is equal to 9, which means my dy over dx equivalent to 9. Okay. So just now my derivative here is negative 9. Okay. So negative 9x square plus 5, sorry, plus 12 plus 12x plus 5 is equivalent to 9. So negative 9x squared plus 12x minus 4 equivalent to 0. Okay, so you can divide with negative. So it's going to be 9x squared minus 12x plus 4 equal to 0. So 3x minus 2 squared. Okay, equal to 0. So my x equal to 2 over 3. So if I want to find the k, I need my y value as well. So we can use from the original equation where y is equivalent to this. Okay, 4, 5, 6, 3. Okay. So 4 plus 5x plus 6x squared minus 3x cubed. So when x equal to 2 over 3, my y equivalent to 4 plus 5 2 over 3 plus 6 2 over 3 square minus 3 2 over 3 square. So which is going to be 82 over 9. So it's given that y equal to 9x plus k. So when x equal to 2 over 3, y equal to 82 over 9. So 82 over 9 equal to 9 bracket 2 over 3 plus k. So your final answer k will be 28 over 9. Okay. Question number 10. An arithmetic progression is the first term A and a common difference D. The second, fifth, and 11th term of the arithmetic is in that order the first three terms of a geometry. Okay, so second term of arithmetic, so T2 is equivalent to 5 plus D. T5 is equivalent to 5 plus 4D. And T11 of an arithmetic is 5 plus 10D. Okay, and they say it's the first three terms of a geometry. So this will be, I just make it geometric 1, geometric second term, and geometric third term. Okay, so since these are geometric progression, so what I know, my R1 divided by T1, so G1 over G2, I'm sorry, G2 over G1 is equal to G3 over G2 because my common ratio must be the same. So it's going to be 5 plus 4D over 5 plus D is equivalent to G3, 5 plus 10D over 5 plus 4D. Okay, so it's going to be 5 plus 4D square is equivalent to 5 plus 10D, 5 plus D. Okay, So 25 plus 40d plus 16d square is equivalent to 25 plus 5d plus 50d plus 10d square. Okay, so rearrange. So 6d square minus 10, 15. 15d equivalent to 0. So d equivalent to 6d minus 15. Therefore, either d equal to 0 or d equal to 15 over 6. So d equivalent to divided by 3 is 5 over 2. So your d cannot be 0. So your d equal to 5 over 2. Okay. For b, the sum of the first 77 terms of an arithmetic and first 10 geometrics is denoted by G10. Okay, so first we find the S77. So first of all, we know for the arithmetic, okay, for the arithmetic progression, my A equivalent to 5 and my D equivalent to 5 over 2. Sorry, okay, 5 over 2. So we find the S77. So it will be 77 over 2, 2A plus n minus 1 d. So when you calculate, you'll get 7700. Whereas for geometric progression, so my first term will be a plus 5 over 2. So will be 7.5, and a common ratio will be 5 plus 45 plus d. So 5 plus 4d over 5 plus d. So my R will be 2. Therefore, G10 will be A n R power of n minus 1 over R minus 1. So it will be 7727.5. Therefore, S77 minus G10 will be 7700 minus 7727.5. We'll get 27.5. Okay. Okay. The function f is defined by fx 3 plus 6x minus 2x. Find fx in the form of a minus b x minus c square, where a, b, c, find the range. Okay. So normally I will use completing the square method for this. If you want to use your calculator, you can proceed, but you must make sure to know what you are writing. Okay. So for fx, I just use my completing the square method. Okay. It's going to be negative 2x squared plus 6x plus 3. So I factorize the negative 2 outside. So x squared minus 3x plus 3. I only factorize for a and b only. For c, I'll leave it like that. So negative 2. So x squared minus 3x plus negative 3 over 2 square minus negative 3 over 2 square plus 3. So negative 2. So x minus 3 over 2 square minus 9 over 4 plus 3. So it's going to be negative 2 x minus 3 over 2 square minus plus 9 over 2 plus 3. So it's going to be negative 2 x minus 3 over 2 square plus 15 over 2. So you can rewrite in terms of 15 over 2 minus 2 x minus 3 over 2 square. Okay, and then the question says state the range. So you can see here is a is negative, so it's going to be a maximum curve. So this point is going to be 3 over 2 and 15 over 2. So which means the range will be fx smaller than or equivalent to 15 over 2. Okay. The graph of y equal to fx is transformed to the graph of y equal to hx by a reflection on axis of the axis followed by the translation. It is given that the graph of y hx has a minimum point. Okay, just now our graph is a maximum graph and now it's become minimum. So this shows that the graph go through the translation on x-axis. Okay, so the graph is reflected on x-axis. Okay, and then now the minimum point is at origin means at 0 0. So now it means it go through the translation. Okay, so initially my graph is something like this. So will be, I just put in this way. So 3 over 2 and 15 over 2. So after it go through the translation, it will, after it go through the reflection, it will something like this. Now 3 over 2 negative 15 over 2. Okay, so which means it must move 3 over 2 units to the left and 15 over 2 unit to up in order it to be here. So now my graph, so they say after reflection is something like this. The turning point is here. This is the turning point. Okay, so it means it moved 3 over 2 unit to the left and 15 over 2 unit up. So translated, so x will be negative 3 over 2 and y will be 15 over 2. Okay, so it moves 3 over 2 units to the left and 15 over 2 units up. Okay, okay, now the function g is defined by this, the graph of y equal to gx as I explained one. Okay, so now they said it is x less than 0 only, the domain is restricted. Okay, so we just draw the simple graph first, or we just sketch a simple one first. Yeah, okay, just now is something like this, correct? So when it says less than 0, only this part is available. So this is no more ready. Okay, it's only this part. Okay, so we redraw. So it's something like this only. Okay, so here will be when x equal to 0, y equal to 3, something like this. Okay, so from here you can say it. So you must justify, explain why g is 1 to, explain why g is 1 to 1 function. Explain. It's not something that you just show like this. You need to explain. Okay. If you notice here, for each and every y value, you have only one x value. You see, you have only one x value. Okay. So that is the explanation for why it has a 1 to 1 function. Okay. So you can say it. Each y value, okay, is associated with only one x value, with only one x value. Okay, therefore they are 1 to 1 function. Okay, and for D, sketch the graph of y equal to g inverse on your diagram C and find the expression of y equal to gx should you label two graphs appropriately with relevant mirror line. Okay, So I just redraw this again. So just now here is 3. So what we know, if it is inverse function, it will be reflected at y equivalent to x. Okay, so will be something like this. Yeah, sorry. It's better for me to draw the line first. Okay, so here will be 3. Okay, y-axis will become x-axis. Okay, so this will be y equivalent to x. This will be y equal to g inverse x, and this will be y equal to gx. Okay, so they ask you to find the equation of a g inverse. So I let my y equal to gx. So will be just now it's actually 15 over 2 minus 2 x minus 3 over 2 square equivalent to y. So I need to make my x as a subject. Okay, I make x as a subject. So you rearrange. So 2x minus 3 over 2 square is equivalent to 15 over 2 minus y. So x minus 3 over 2 square is equivalent to 15 over 4, y over 4, sorry, y over 2, y over 2. Therefore, x is equivalent to 3 over 2 plus minus 15 over 4 minus y over 2. And if you notice, just now the graph here, okay, it's supposed to be like this. Okay, so if you take this axis symmetry, and the graph we draw here is actually only this part. So this indicate here is we only have a negative. So my final answer g inverse x will be 3 over 2. We will ignore the positive part because we take the left hand side of the graph. Okay, so 3 over 2 minus third 15 over 4 minus x over 2. Okay, so that's all for paper 1. Thank you.